Hello and welcome to the presentation of Smartbright, our outcome-oriented smart home control application. The application itself is divided into three parts: a manual mode, a room overview, and an automatic mode. In the manual mode, users can control a smart home as they are used to by setting sliders and seeing the changes in real life. In this case, we are using a simulation. We use a ray tracer for light, but the principles are usable in other domains as well. The idea is, if users have a specific target setting in mind, for example, they want to have a specific brightness, for example 4.5, all they can do is play around with the settings until they maybe reach the target they were looking for. For example, here it's way too bright, it's at 5.35, and here it's at 4.5. It's about what the user wants. But as soon as the time changes, and we are, for example, approaching night, the same settings will no longer lead to the results we used to because, well, it's night and the on-set conditions changed. So the user, if they want to have a constant brightness throughout the day, will need to play around with settings all day long. Instead, we have used one of three methods in Smartbright called SymBS and SymUC, which we will shortly explain in the paper. With those, we can learn how the environment and the actuator settings affect the perceived values. For example, in this case, how do the lamp and the window blind affect the perceived brightness? With the goal of being able to set a target brightness. For example, I want to have a target brightness of 4.44 at night. Well, our smart home figures out. How does it figure it out? It has learned equations that describe this and that times lamp plus this and this time blind divided by time or whatever equals brightness. So we have an equation that describes how the lamp and the blind and the time affect the brightness. If we rearrange the equation, if we solve the equation for possible inputs, suddenly we can set a target and our smart home finds ways to reach that. The interesting part is we can even set that we don't want specific solutions. For example, we don't want to use the lamp if possible. So you see, it tries to find solutions without a lamp. Unfortunately, during night, if we actually turn off the lamp, well, it's too dark because it's night. So we have included a fallback mechanism that overrides this if we, well, wouldn't reach the goal. For example, during the day, if we want to have a target brightness of 4.7, well, our application is able to find solutions without lamp, which is a cool thing. Similar, we can say, okay, we want to solve our equations only with a lamp, if possible. And this is especially important during night. When during night, well, the lamp is the only source of light and we don't bother for the blind. So this is an overview of our application. Please feel free to read our paper for more details.